Today we're gonna talk about Taylor polynomials.
Sorry, I'm so late.
I'm sorry, you're 5 seconds late. Get out. Get out. Alright. So first of all, we're gonna teach you the definition of a Taylor polynomial. What is a Taylor polynomial? Taylor polynomial is a representation of a functions as an infinite sum of terms that are calculated from the derivatives of that function at a single point. So, who here wants to show me the basic structure of a Taylor polynomial? No, Diego, not you. Numa, come here to the board. Show me how to do it. Hey, how do you construct the basic structure of a Taylor polynomial? Please, tell to the class.
Okay, so this is the basic.
Speak loud.
This is the basic. The basic structure of the Taylor polynomial. So first, you use the function f of a.
Yes.
Plus the first derivative of a over 1 factorial.
Yeah.
Times x minus a to the power of 1.
Yeah.
And then you do the same thing for the second derivative of a over 2 factorial
Speak loud.
times x minus a to the power of 2. And all this until you have f of the f n of a over n factorial x minus a to the power of n.
So now we're gonna find the second degree Taylor polynomial of f of x of the cubic root of x. So how can we express the cubic root of x in another way? Just write f of x equals x to the 1/3. Now we find the first derivative of that. F of x equals 1/3 of x, and then 1/3 minus 1 minus 2/3. Through this we find the second derivative. Second derivative of x equals minus 2, 9, and then minus 2/3 minus 1 minus 5/3. So after we found out the second derivative, sorry, forgot the x. After we found out this, because our value is x equals 1, we're gonna plug 1 into the function. So f of 1 equals cubic root of 1 equals 1. Now, f prime of 1 equals 1/3 of, now we're gonna put this value down, so it's gonna be cubic root of 1 to the power of 2, which is equal to 1/3. Now, our second derivative of 1 equals minus 2 over 9, and then we're gonna put this down, so it's gonna be cubic root of 1 to the power of 5, which is equals to minus 2 over 9. So now, after we have this, who wants to write it as Numa did at the beginning? Shasha, you want to write it?
Sure.
Go ahead. Use black pen, please.
Yeah, thanks.
So we write p of 2 because it's the second degree polynomial.
Times 1/3 as you got the value of 1 when plugged into the derivative as 1/3, and then you multiply it with x minus 1, and then you minus 1 by 9 and multiply it with x minus 1 to the square root of 2. So this is the second degree polynomial of the function cube root of x.
Okay, Shasha, you wanna do another one?
Definitely, professor.
Alright. Now find me the second degree Taylor polynomial of f of x equals e to the power of x about x equals 0. How do you do?
Definitely. So the first derivative of x is actually equal to e of x, and it's similar for the second derivative of x2. And about values of the x at the first and second derivative will be calculated as, so f at 0 is 1 and f at second derivative of 0 is also equal to 1. So to write the general formula of the Taylor polynomial, because it's second degree, I'll write it as f of a plus f first derivative of a and 1 factorial and x minus a, that. And I'll add it to the second derivative of a, to the second derivative, and x minus a squared. So the final answer would be 1 plus x squared by 2. And if some of the students don't understand what the factorial means, 2 factorial is basically 2 times 1, and 1 factorial is equal to 1. And if it's 3 factorial, it's 3 times 2 times 1. Thank you, Professor. Is this correct?
You did a very good job, Shasha.
You say that, but my high school teacher told me that I was average in math.
That's very mean.